In level 2, we will be reviewing solving log and exponential equations and also determining whether a table represents an exponential or a linear relationship. So the first part is reviewing solving exponential equations. We want to get our exponential expression by itself, so we want to isolate e to the 4x in this first problem. So I would divide both sides by 36. And I get 2 equals e to the 4x. Now, once you have your exponential expression isolated, there's kind of two ways you can think about your next step. One method is to change it to log form. And if I do that, I would get log base e, or natural log, of 2 equals 4x. The other method that you could use is to take the natural log of both sides. So if I take the natural log of both sides, I get ln of 2 on the left side, and the natural log and the e cancel on the right side, and I just get equals 4x. So either way, I get natural log of 2 equals 4x. Then to get x by itself, I divide both sides by 4, and x equals natural log of 2 over 4. And this is exact form. It's not the same as natural log of 1/2. If I divide the 2 by 4, I'm not allowed to do that. Natural log of 2 is its own number, some weird decimal that is then divided by 4 if I wanted to change it to a decimal, but it's okay to just leave it in exact form. In the next example, remember that we're trying to get x by itself, and x is being multiplied by some goofy number, e to the 0.08 times 25, and e to the 0.08 times 25 is just some number, and I can divide both sides by that number. I can simplify it a little bit if I want. 0.08 times 25 is 2. So this is the same as 518 equals x times e to the second. But to get x by itself, all I have to do is divide both sides by e to the second, which is just some number. And I get x equals 518 over e to the second. And that is exact form. Again, I could change it to a decimal approximation if I wanted, but exact form is just fine. The next part of level 2 is determining whether a table represents a linear or an exponential function. Remember, a linear function can be written in the form y equals mx plus b, where m is the slope, or the rate of change, and b is the y-intercept, which also happens to be the y value when x equals 0. And a linear relationship is an adding or a subtracting pattern. So if we have a table where the x values are going up by 1 and the y values add or subtract the same amount from one to the next, that's going to be a linear relationship. An exponential relationship can be written in the form y equals a times b to the x power, where a is called the initial value and this also happens to be the y-intercept, or the y value when x equals 0. And b we call the growth factor. Or it could be a a decay factor. So in a relationship, an exponential relationship where the numbers are getting bigger, it would be a growth factor when b is greater than 1. And if you have a relationship where the numbers are getting smaller, we would call it a decay factor, and b would be a fraction like 1/2 or a decimal like 0.05. Something that is between 0 and 1 would be exponential decay. Okay, so looking at these tables, we have x values increasing by 1, so we look at the relationship between the y values, and in the first table, it looks like we are adding 2 from one y value to the next. Since it's an adding pattern, this is going to be a linear relationship, and the slope is going to be 2. Now, if my table didn't have x values going up by 1, I would have to take 2 points and use the slope formula to get the slope. But in this case, since we're going up by 1s, that number we add from one to the next is going to be the slope or the rate of change. And the y-intercept is going to be the y value when x equals 0, which is 4. So the equation of this line is y equals 2x plus 4. In the next table, the pattern is multiplying by 2. From one y value to the next, we multiply by 2. And again, the x values are going up by 1. So this is going to be an exponential relationship. And we want to write it in the form y equals a times b to the x. The a value is going to be the initial value or the y value when x equals 0. So it's the y-intercept, which in this case is 4. And then this is a growing or an increasing relationship, so the growth factor is going to be that number I multiply by from one to the next, which is 2. So 4 times 2 to the x power is what we get. Now, one other thing, if you have a relationship where it's decreasing for exponential, don't think of it as what you divide by, think of it as what you multiply by. So if you have a table where it seems like the y values are being divided by 2, that's the same as multiplying by 1/2, and your decay factor would be 1/2. So it's always what you multiply by from one to the next.